Okay, so now we'll talk about acceptance criteria and design validation. For plant maintenance work, our requirement is that the engineer of record documents the expected ranges of operations that the system is going to have in a set of acceptance criteria. Those acceptance criteria need to be in the contract documents, and we are going to measure them directly during commissioning. So the design engineer says at noon on Tuesday, the fan power is going to be 8 horsepower, plus or minus a half. Well, then during commissioning, we're going to measure at noon on Tuesdays what is the fan power, and we expect it to be 8 horsepower, plus or minus a half. So it's kind of a simple concept. We would call it simple but not easy. And when we're talking about this, I always remember this kind of story. Several years ago, I was having dinner with some designers, a couple of designers in San Francisco, and one of them was a mechanical engineer and another was an electrical engineer. We had a nice dinner there. There was some wine, and at one point in the conversation, the electrical guy asked us mechanical dudes a question. He said, you guys know, right? If it's 10 o'clock in the morning and it's 77 degrees outside, you know how much fan power should be used in the building, right? Or you know how much cooling power there should be in the building, right? And me and the other mechanical guy looked at each other. We were quiet for a second, and then we both laughed and said, well, no, we don't know that. We don't do that calculation. We'd really have to go back and look at the math and figure it out. And I always remember that evening because I realized immediately that we should and we need to. In order to validate that we have a design that works, we absolutely need to know those values or at least know those ranges. If it's 10 o'clock in the morning and 77 degrees outside, we've got to know how much fan power should be used, or at least the maximum amount of fan power that we expect to be used. We've got to know how much cooling power should be used. We've talked about in our design reviews that we tend to do energy calculations in annual units, so kilowatt hours per year, or therms per year, or kBTUs per year, or dollars per year. That's kind of how our industry standards work. But if we go off track in the first hour, then we're not going to hit the first monthly target, let alone the first quarterly target or the first annual target. So while our industry standard is to express energy calculations in annual units, we have to be able to express them in hourly units because that's what we actually have on the ground. The good news about hourly energy targets is that you'll know in day one and hour one whether the design assumptions were correct. And the bad news about hourly energy targets is that you'll know in day one and hour one whether the design assumptions were correct, right? So in this paradigm, let's talk about the role of the designer. We've been doing these acceptance criteria for a couple of years. If you've been doing Kaiser work, you've doubtless seen them. And we have a template, and we've used our commissioning agents for acceptance criteria, or my engineers for acceptance criteria, but we've come to realize, particularly in the last year, that the acceptance criteria have to be by the design engineer. Nobody but the design engineer can own these. What we found in 2021 was that acceptance criteria were being changed, sometimes during commissioning. So we had criteria that was out there, and sometimes they were issued by the engineer, sometimes they were issued by my team, sometimes they were issued by the commissioning. And then during commissioning, the numbers start coming in and they're radically different. And so the commissioning team, wanting to move things forward, just moves the marker up to some other number and then passes that. So in 2022, we're tightening down the screws on that. We're implementing an acceptance criteria change process, which is that the acceptance criteria go into the contract documents, and then once they're in the contract documents, if you need to make a change, we do that in the same way we would make any other change to contract documents. The engineer of record issues a change with a reason, and then that goes out to the contracting team and the commissioning team in the traditional manner. Here's just an example of acceptance criteria on the plans. This is a sheet in the controls drawing that has acceptance criteria listed on it. So this is what we'd really like to see. Another thing that we've realized is that acceptance criteria and controls design really is a team effort. In my day as a design engineer, when I had to write a sequence of operations, the way I did it is I would drink 3 cups of coffee on Thursday afternoon at 4 o'clock, and then I would dive in and plow through till 9 o'clock. I'd try to imagine every possible detail and write it out, caffeine sweating out of every pore. But to be brutally honest, that sequence is not going to work. Because it has to be the team effort, the controls vendor, the commissioning agent, the operations folks, the Kaiser engineering team, the equipment vendors. Those are all stakeholders in those sequences. So those sequences need to be they need to work for everybody. They need to be understood by everyone. We've seen this really more than anywhere else on rooftop package units. The sequence that I would have written up, in my caffeine-induced frenzy, and the sequence that actually arrives on the job site with a standard train unit are two different things. And so that all needs to get vetted out and hammered out during the design phase. It really does take a village to write these sequences and the acceptance criteria for them. So we've also established minimum acceptance criteria to demonstrate our design intents. And I don't mean minimum like minimum numbers. I mean, there's a minimum quantity of acceptance criteria that's needed to prove out the design intents. We've come to realize that there are 4 categories of acceptance criteria. We have our systems in control criteria, our turn up and turn down criteria, our efficiency criteria, and then what we call the non-trended points that are more binary in nature. So just as an example, if we have a boiler, first we would want to see that the temperatures are in control and the pressures are in control and the flows are in control. That's what we would call systems in control criteria, and those are prerequisites to anything else. Next, we should see turn up and turn down. We should see things shutting off at night and turning on during the day. We should see a boiler ramping up when it's cold and ramping down when it's warm, right? That's a turn down criteria. Then we want to see efficiency. We should look at the BTUs in the heating loop and divide that by the BTUs in the gas line, and we want that number to be better than 80%. And then, of course, we have these binary criteria, these yes, no, check the box type of criteria, things like failure modes. For electrical systems, there's a whole lot of non-trended acceptance criteria. So my group maintains a template of these acceptance criteria, and I will emphasize the word template. This is not a standard, it is a template. I'm very glad that we have it, so design engineers can lean on it. It definitely shows what acceptance criteria look like, but we do need our design engineers to own their own acceptance criteria for their own designs. If the template says a half a watt a square foot, and you go and put that on your plans, then when we go to check it during commissioning and the system is using triple that or quadruple that, we're not going to be happy to hear, well, that was the number, we just pulled it from the Kaiser template. That's kind of the wrong answer. We do need you to check those acceptance criteria as they're going out onto plans. We'll talk a little bit more about that. So to wrap up here, for plant maintenance work, our requirement is that the engineer of record documents the expected ranges of operations that the system will have in a set of acceptance criteria. Those acceptance criteria need to be on the contract documents, and then we're going to directly measure them during commissioning. So that's the end of this chapter 2. I'll remind you again to put any questions that you have about acceptance criteria into the chat box.
Is there a baseline acceptance criteria from KP that should be used when conducting the initial assessments for existing buildings before rework has been done?
We have a template for acceptance criteria. That is a pretty good guideline. I think the template that we have is in version 5 or 6 of publication. So the values that are sitting in there are pretty well earned. But I think, as I mentioned here, that it is just a template, and so the designers do need to reconcile their own design against those template values.
Where can we get the historical data from eBuilder?
Where can we get historical data from eBuilder? Well, okay, so I'm hearing that question 2 ways. So the first one is, if you're talking about the historical load data, then we've got that published out on a public video. It's actually a YouTube video that's going to be part of this California decarbonization project, and so that'll be public and widely available for historical loads. I think, though, that this question may refer to, hey, I'm just starting a project in a building. How am I going to get a hold of that utility data or the interval data on the utilities or the data that's coming from the building automation system on that building, a year's worth of data? And so that's going to come from my team. And what we're starting to do is, as we get into the OPR phase, We know that a project is coming at a building. The project manager is writing an OPR, and so we'll go and pull down that utility data, request that interval data, and just drop that data up into the folder of eBuilder, so that by the time you come along to do your design, it's sort of sitting there waiting for you. Ideally, that's sort of how it would happen. If it's not, then you would simply ask. I have an engineer assigned to every project. And so we'd always be able to dig in, and it's pretty quick. We can assemble data pretty quickly for these projects.
Is there a proposed mechanism to obtain zone level issues in a building? Would we expect facility engineering support the design engineer to identify these issues?
Yeah, so there's three levels to that. If we have our Clockworks, our fault detection and diagnostic system installed, then we'll be able to see that live. We'll be able to see real data in the diagnostics. So the zones that are acting out will have faults associated to them, and so you'll be able to see those. And similarly, the zones that do not have faults, it is reasonable to assume that they're not acting out and they're not out of whack. If we don't have that diagnostic system involved, then the next level would be the BAS itself, and looking for alarms within the BAS, zones that are out of temperature or zones that are, over temperature. That's where we would look phase 2. And then the sort of lowest form of data, obviously, is expert opinion, but that's where you would ask for that. So an interview with the facility engineer to say, what are the zones that, what are the 5 zones in this building that are out of whack or causing you problems? They definitely know where those zones are. And if you walk into a building where they don't have any trending capabilities, for example, then that's when you might initiate trends on the zones that are indicated to gather some data to use in the assessment.